All right, today we are in section 7.3, which are the arcs of circles. So we're going to start with some vocabulary, starting with examples of minor and major arcs, and then we have our definition. So a minor arc, it's really important. Minor arcs are only named using two letters. And then we put an arc symbol above it. So we use two letters to name a minor arc. And a minor arc is an arc on the circle that measures less than 180 degrees. A major arc uses always three letters to name the arc. And it uses that arc symbol. And this is another arc that's on the circle. That measures more than 180 degrees. And it's always going to be less than 360 because 360 degrees is a full circle. Next, we have, what is the relationship between a major arc and its corresponding minor arc of a circle? And the relationship is that when you take a minor arc and add it to a major arc, the two of them combine to get you 360 degrees, okay? So they add up to 360 degrees, and 360 degrees is a full circle. Our next definition is a semicircle, and a semicircle is a half circle. What's important about a semicircle is that a semicircle always measures 180 degrees. All right, the arc measures exactly 180 degrees. And with a semicircle, there's something important that we have to draw in our semicircle. And this is what we're always going to be having to highlight, because once we highlight what's called the diameter, all right, diameter creates two semicircles. So once you have a diameter, I'm going to use a color and I'm going to highlight the diameter. Always highlight the diameter, because then you know that you have a semicircle, half a circle. So the first theorem that we have is the central angle and arc theorem. It tells us that the arc of a circle is the same measure as the central angle that forms the arc. You can also say that the central angle of a circle is the same measure of the arc formed by the angle. So here's what you have to know. Your arc always equals the central angle, and the central angle always equals the arc every single time. Those are completely equal. The next one, we have a semicircle. The central angle of a semicircle is always equal to 180 degrees. And then the central angle of an entire circle is always equal to 360 degrees. So everything that we do today is going to be like one big puzzle that we're going to have to use our calculator in order to figure out. You're going to always highlight the diameter, because then you have semicircles. Central angles are equal, and all the arcs of a circle add up to 360 degrees. So when we go through this, it says, given circle A, find each of the following. All right. If I have a diameter, you're going to highlight it. And in this picture, I have a diameter. So since I have a diameter, I'm going to go ahead and highlight the diameter, because the diameter splits a circle into two semicircles. We have one half and the other half. Starting with the measure, so that little m means measure, the measure of arc, FB, because it only has two letters, we're going to go the shorter distance from F to B. This is what's called a minor arc. All right, so from F to B, we want to find this measure right here from F to B, and the 60, which is in the center of the circle, is going to be equal to that minor arc, right? That arc that it's formed. So we could put 60 right here. Those are equal. So we have 60 degrees. In number 2, we have the measure of arc CB. So once again, this only has 2 letters. So this is a minor arc. It uses 2 letters. And I'm going to highlight that CB right here. And I notice that the central angle right inside of it is 52. Therefore, CB is also going to be 52. So we have 52 degrees. The next one that we have is the measure of CD. So it's got 2 letters. This is a minor arc. And let's see, CD on the circle, it's an arc measure, is right here. Well, that box in the corner would be 90 degrees. So since that's 90 degrees, it's going to be equal to this arc. So this is also going to be 90 degrees. The next thing that we're looking for is the measure of arc EB. So notice that from E, it doesn't matter which way you go, E to B, that whole thing is a semicircle. No matter which way you go from E to B. So semicircles can either be named with 2 letters or 3 letters. Knowing that it's a semicircle, it's always 180 degrees. The next one says, find the measure of arc EF. So from E to F, we have to go the short distance from E to F right here. All right, and to find EF, so that's a minor arc, what we're going to do is we're going to subtract, because from E to F, if I complete this from and then going to B, that's half a circle. That's a semicircle. So because we have a semicircle right there, what we're going to do is take 180 minus 60, and we're going to get our final answer for this missing piece right here, 180 minus 60, so we have 120. So we have 120 degrees. We have the next circle. Every single time, we are always going to highlight the diameter. So in this picture, I take my highlighter tool and I highlight from S to A. We have that segment SA. So now the diameter splits up the circle into 2 semicircles. The first one that we have, number 6, it says the measure of arc RA. So I'm going to go the shorter distance. This is a minor arc. And this minor arc is right here. Here's RA. Now the problem is that it's 20x plus 1. That doesn't help me. That's not a measure. That's not a number. However, this RA is next to SR, which is 99. And from S to R, and then if I were to connect R to A, they're not going to be equal to each other. What I can do is add the 2 of them together. And set it equal to 180. And that's the point of highlighting the diameter, because the diameter splits up the arcs into semicircles. So now we can go ahead and solve. All right, we should get the answer, which is 4. However, that's not our final answer. What we're going to do is we're going to have to plug that in. So we have 20 times 4 plus 1, which equals 81 degrees. So that's the measure of arc RA is 81. Now the next one says the measure of LA. However, from L to A, it has an X, and we already found X. X is 4. So all you have to do is plug that in. So we have 25 times 4 minus 17. And I know that I'm going the shorter distance from L to A because it's got 2 letters, making it a minor arc. So we have 25 times 4 minus 17, and you get 83 degrees. So this is 83 degrees. The next one says, find the measure of arc SLR. So this is a major arc because it's got 3 letters. So I'm going to go ahead and highlight from S to L, and then I have to keep going all the way over to R. So not only does it include that semicircle on the left-hand side, which is 180, I'm going to add that 81 in blue to get the actual number, which equals 261 degrees. So that major arc from S to L past the A going over to the R is going to be 261. And again, I did that because we have half a circle, we have a semicircle, which is 180, ending from S to A, and then we add just a little bit, that 81, and we get 261. Number 9, this has got 3 letters, making it a major arc. So we have from L to A, and then all the way over to S. So we have from L to A, and then I just got to keep going all the way to S. So I'm going to take our 3 numbers that we have. We've got 83 plus we've got 81 plus we've got that 99, and those 3 added together equals 263 degrees. This is our final picture, the final type of circle that you could have. These all have x. It's 8x minus 6. We've got 5x. We've got 10x plus 20. And we've got 7x minus 14. What we're looking for in each of these, we've got minor arc, major arc, major arc. But there's actually no numbers, all right? So in order to find our answer, the final way that we could have our pictures is a full triangle. And in this picture, they gave us a full triangle, all with x's, and all triangles add up to 180 degrees. So before we answer each of the questions, what we're going to have to do is take all 3 arcs. We've got 8x minus 6 plus 5x plus 10x plus 20 plus 7x minus 14, in all 4 arcs, the whole circle is 360 degrees. From there, we're going to go ahead and solve for x. So from there, go ahead and plug each of them in. So I can plug in this 5 times 12, and we get 60. We can do 10 times 12 plus 20. 140. We could do 7 times 12, which is 84, minus 14, which is 70. And then I could do 8 times 12, which is 96, minus 6, which is 90 degrees. From there, you just have to figure out if it's a minor arc or a major arc. Are you going the small distance or the large distance? So for number 10, we have a minor arc. We have from M to A, and we got that was already 60 degrees. The next one that we have in number 11, this is a minor arc. It's got 2 letters. We're going from M to H. Now for this problem, you have to go the smaller distance from M to H, not the bigger distance. So I'm not going to take 140 plus 70. That's going to give me a number over 180. I'm going to go the smaller distance. So we're going to take 90 plus 60. The shorter distance, because it's specifically 2 letters and it's a minor arc, and we get 150 degrees. So that one could be a little bit tricky. You have to make sure that you go the correct way. 2 letters from M to A is from here to here. So it's bypassing the, oh wait, this is A to H. So it's bypassing the M, going straight from M to H. All right, this next one, it's got 3 letters. So we've got M to A and then all the way over to T. So that's a major arc because it's got 3 letters. So you're going to start at M, go over to A, and then finally you're going to end at T. So we've got 60 plus 140, which equals 200 degrees. And then last,